We are now going to write equations from word problems. This isn't as bad as it sounds, so let's get going. This says Mr. LaFleur pays $130 to rent a car for 1 week. He also pays $5 for each 100 miles that he drives. So let's just go step by step. The first says to define variables using let statements. Decide which variable will act as your independent variable x and which will act as your dependent variable y. Well, the question that this thing asks is this whole thing about how many miles he drives and then how much the car is going to cost. So really what I'm going to do is I'm going to say let, and we're not going to use x and y. I'm going to use different ones here just to kind of do that. We're going to say m maybe for miles, or you know what, let's use d for distance because that's more commonly used. And then this is going to be a capital C for cost. So I'm going to say let d equal the distance he drives. And we can do miles. We can also do 100 miles. So let's do that. We're going to go in 100 miles. So that means I'm doing it in units of 100 miles. So that's going to simplify things a lot because 1 will be 100 miles, 2 will be 200 miles. And then I'm going to let capital C equal the cost to rent the car in dollars. Okay, 2. Decide if the problem tells me anything about an initial condition, a y-intercept, and a rate. Now, this initial condition is a commonly used language to mean like a starting point, or what we like to call a flat cost. That's a big one, that flat cost. How much it costs no matter what. And that's a y-intercept. So for step B, my y-intercept, my flat cost, is this $130 that it costs to rent it no matter what. I have to pay that even if I drive 0 miles. And then a rate. A rate's going to be a slope. $5 for every 100 miles that he drives. Well, that's $5, so that rate, or that slope, that's going to be, it would be 5 over 100, but I did the d in distance in 100, so it's just 5 over 1. $5 to every 100 miles. So my slope is just 5. Step C, we're going to use the information to write an equation in slope-intercept form that shows the relationship between the total cost of renting the car and the number of miles that are driven. Well, that's just y equals mx plus b. Well, I don't have y, I have c. This c right here is acting like my y, and this d is acting like my x. So I actually have c is equal to md plus b. Really, I'm just replacing the y and the x here. And furthermore, I don't have an m and a b now. I know what those are. So let me kind of erase this, and we're just going to go cost is equal to slope is 5, x I really have d, and then plus b is my y-intercept, 130. So I get c is equal to 5d plus 130. Cost is equal to 5 times the distance I drive plus 130. Then next step. Let's go step D. It says graph the line by scaling the axes appropriately. Clearly label each axis with units. Well, what I can do here is I can just do a little t-chart. I'm going to have D and C. And for the D, I'm going to say, well, at 0, I have to spend $130. At 100 miles, I have to spend $135. At 200 miles, I have to spend $140, and you can see what's happening here. So I'm going to do a very basic graph here. I don't want these to be terribly complicated, but I'm just going to put a few points down here. I know that at 0, let's see, when I do 0 distance driven, I do 130. So this is 0, 1, 2, 3, 4, and 5. And this, when I say label the axis, this is number of 100 miles driven. And the vertical is just the cost. So I have 130, 135, 140, 145, and I'm just going to put some points down. 0, 130, 1, 135, 2, 140, and just get kind of a line going that way. That's a little sketch. We'll do a better one here in a minute, but I want you to see that you don't need to have that much down to show kind of what's happening here. It's a linear relationship, and it's linear because, you know, basically I can kind of match and say, yep, at 300 miles I have to pay $145. I'm also going to put a little break here because I skipped between 0 and 130 on the y-axis. Oops, I forgot cost in dollars here. So that's kind of a single problem. Let's show some other ones, what we can do with this. And I'll use some graph paper on the next ones to make it a little bit more clear. Okay, an author sells his latest book to a publisher for $5,000 plus $3,000 for every 1,000 books that are sold. Write an equation. Well, we're going to want to use variables. Let's use x and y here. We're going to let x equal the number of 1,000 books sold. I know that because it says for every 1,000 books that are sold. And y is going to be equal to, and I'm not going to use capital letters for the y because I don't have to. I've already labeled it a y. It says the relationship between these authors' income and the number of books that are sold. So this is going to be the author's income in dollars. Okay, so now we have, let's see, I want to look for that y-intercept, that starting point. Well, it says an author sells his latest book to a publisher for $5,000. So the author gets $5,000 no matter what. And then the slope is 300 to 1. 300 for every 1,000 books he sold. Now, it's not 300 to 1,000 because we said that x was the number of 1,000 books sold, so we've already accounted for that. So now we hit up the, let's see, the equation. We're going to go y is equal to 300x plus 5,000. Then it wants a graph. So I promised that we'd do a real graph. Let's turn on some graph paper and get a good first quadrant graph going. I'm going to do it over here on the side. And then we're going to have a t-chart where I have x and y. And when x is 0, y is 5,000. When x is 1, y is 5,300. When x is 2, y is 5,600. I'm literally just plugging these in here. And you can see once you get the pattern going, what's happening with the y's. It's just increasing by the same amount. Let's get 5 of them down there. And then what I'm going to do is label my x-axis. Here's 0, 1, 2, 3, 4, 5. And my y-axis, I'm going to skip over a bunch and start at 5,000, 5,300, 5,600, 5,900, 6,200, and 6,500. And then I'm just going to label some points. And label those points in a different color. 0, 5,000, 1, 5,300, 2, 5,600, 3, 5,900, and so on. And then we connect those. Oops. And you can go ahead and label your axes now, because you don't want to leave it like this. We need a label. So I'm going to label this x-axis number of 1,000 books, and the y-axis will be income in dollars. And that little chart just tells you if you sell how many 1,000 books, how much money you can be expected to pay or to get paid. Okay, number 3. It costs $8 to enter an amusement park and 35 cents per ride. Sometimes we can look at these and kind of see before we even start that that's going to be like a slope, and this is going to be like a flat cost. And the flat cost acts as the y-intercept, and the 35 cents acts as a slope. But before you write that, we need to define variables. So I'm going to say let x equal, it talks about number of rides, and then the y is going to be equal to the cost. And we'll want to do that. We can do it in dollars or we can do it in cents. Let's do it in dollars, just because we use dollars in this world now. So then my equation is going to be y is equal to, my slope was 0.35 cents per, dollars per ride. X is the number of rides, and then plus 8 is the flat cost. And you can check that if you plug 0 in and you ride no rides, you'd still have to pay $8. Then the next question says, how much would someone spend at the park who goes on 9 rides? So x is the number of rides. I'm just going to substitute 9 in. Then I'm going to do 9 times 35. We can do that really quickly over here. Let's see. So that's 3.15 plus 8. And that's 11.15. So you'd spend $11.15 to go on 9 rides. And then it says, how many rides could someone go on without spending more than $15? Well, $15 is a y. So that's going to get plugged into the y right here. I'm going to go 15 is equal to 0.35x plus 8. Subtract 8, and I get 7 is equal to 0.35x. If I divided both sides by 4, let's see. Actually, I'm going to, well, I would cheat and divide both sides by 7 and then clear that, but let's just divide both sides by 0.35 and keep it simple. And since I don't want to turn away to a calculator, I'm going to go 7 over 35 is the same as 700 over 35, which is 20. So how many rides could someone go on without spending more than $15? That would be 20 rides. You could go on 20 rides, still not go over $15. Next, it says Mrs. Swanson drove 300 miles one week in a rental car. The total cost of renting the car was $120, which included the weekly rate plus a mileage charge. Another week, she drove 560 miles, and the cost was $133. So what we actually have here is kind of different. We have 2 ordered pairs, and we just want to decide what order to put them in. So it says write an equation. Well, we know the first thing we need to do is the let statement. We're going to let x equal number of miles driven. I'm not going to say number of 100 miles because here we drove 560 miles, and that would give me a decimal, and I really don't want to do that. Then we're going to go let y equal the cost in dollars. And then I'm going to build my 2 ordered pairs. 1 week, if I drive 300 miles, it costs $120. Another time, if I drive $560, it costs, or 60 miles, it costs $133. I know that if I have 2 points, I can get the equation of a line. I can do that by first finding the slope, 133 minus 120 over 560 minus 300, and that's going to be 13 over 260, which is going to simplify to 1 over 20. So there's a slope, and then I'm going to do point slope form. Y minus y1 equals slope times x minus x1. Y minus, let's just pick the first point, 120 is equal to 1 over 20 times x minus 300. And we're going to put that in slope-intercept form. Y minus 120 is equal to 1/20th x minus 300 over 20 is 15. And then I'm going to add 120 to both sides. And I get y is equal to 1/20th x plus 105. All that to get this equation. Now, what can we do with it? Determine the charge per mile and the weekly rate. Okay, well, charge per mile is the 1 over 20. And what that means is $1 per 20 miles. That's kind of the easiest way to say it. Charge per mile would just be $1 for every 20 miles. And then the weekly rate, well, that's kind of a misnomer. The weekly rate is a flat rate. It's how much you pay that week no matter what. And that flat rate is the y-intercept, and that's the $105. You pay that no matter what. No matter how much you drive, you're going to pay the $105. Then it says determine the cost of renting the car if it's driven 800 miles per week. So if we drive it 800 miles, then I go y is equal to 1/20th times 800 plus 105. And that's going to be 40 plus 105, or $145. Then finally it wants us to graph. This should actually be the easiest thing, because what I'm going to do is just take the equation that we have at the start, and I'm going to say, let's say that I've got, well, x and y, and 0, and I start at 105. Now I could do 1, but I don't want to add that. I want to get these to be something reasonable, something that I would actually kind of maybe drive. So let's increase it by like 100 miles. And so if I drive 100 miles, I'm going to go 1/20th times 100, which is 5, and then add that to 105, and that's 110. And then 200 miles would mean I get 115. And 300 miles would be 120. And 400 miles would be 125. That's much more reasonable to graph because that's more meaningful. So then if I graph that just on a first quadrant graph, I got 0, 100. Notice how I'm spacing this out a little bit just so I can draw it easier. And I'll space these out too. 0, 105, 110, 115, 120, 125. Put some points down and create a break line here, then a point here, then a point here, then a point here, then a point there. Connect them, maybe go a little further and show that that goes forever, and then label my axes. My x-axis was number of miles driven, and my y-axis is the cost in dollars. So that's kind of it for those. One more little thing, this is not that bad. This talks about kind of reading a graph. Danielle works at a shipping company, and you have number of boxes packaged and the time it takes. So the first thing says, what is Danielle's rate of change in the first 10 minutes? So in the first 10 minutes is this part right there. And at the end of that first 10 minutes, she has packaged 50 boxes, and that's in 10 minutes. So that's 5 boxes per minute. That's what we mean by a rate of change. Then it says, what does the horizontal line segment represent? You can kind of predict that. She's still the 50 boxes packaged. So you could say no boxes packaged. You could be a little clever and say that this was like a lunch break, or just a break or some time for 20 minutes where she wasn't working. Then it says, what's the rate of the change in the last 20 minutes? Well, this is a little bit trickier. I can look at that and I can think of a rate of change. Remember, rate of change is a slope. So slope is a rise over a run, and it's not up 2 over 4. It's actually up 20 boxes and then over 20 minutes. So it's 20 boxes over 20 minutes. And if I have 20 boxes over 20 minutes, that's just 1 box per minute. So she was a lot faster at the start of the job than she was at the end. So what is her rate of change last? And it says, what does that rate of change represent for this situation? That would just be slowing down somehow. It was slower than the start was. So maybe that's the end of the day, or I don't know, it's a 15-minute day, so that makes sense. Okay, that's it.